Hey, Dr. Romano, looks like you're up to physics. Is that Newton's law?
Yes, it is. I'd like to go over a question with you today on the second law of Newton. This law is going to say that force is directly related to the mass and force is directly related to the acceleration. Therefore, we come up with the famous equation F equals ma. Let's have a look at an example. A 1,300 kilogram car moves at 20 meters per second, is to be stopped in 80 meters. Find the stopping force. The first thing we do is we write down the equation F equals ma, which is the second law of Newton. Now, we know the mass is 1,300, so that's easy enough, but we're not given the acceleration. We're given the initial velocity, we are given the total distance, and if you notice, it says stopping force, which means that the final speed when it comes to rest will be, the final velocity will be 0. So therefore, we got to put a formula together that's going to have these variables in it to solve for acceleration. And that's going to be this formula here. V final squared is V initial squared plus 2as. Since it's a stopping force, the final velocity is 0. The initial was 20. We square it. We don't know a. The distance was 80. You bring this to the other side. You get minus 160a is 400. And we get negative 2.5 meters per second squared for the acceleration. Since there's a negative in front of it, it's actually decelerating. But we're using the same formula. Now that we found the deceleration, we plug it into F equals ma. We know the mass, we know the deceleration, and we get the force minus 3250. Notice the minus simply means it's a stopping force. So the force, the magnitude, would be 3250 newtons. Part B, if we increase the time of a collision, what would happen to the force? Well, all you would do is write F equals ma, but instead of putting in a, we're going to put in what a is equal to. Acceleration is equal to the change in the velocity over the time. So if you increase the time, you would decrease the force. Hopefully you can see what I've done on a type of question that you would see on an OAT exam on the second law of Newton. All right, I hope this gives you an idea on how to do some of the problems that you're going to encounter, and I have a whole bunch more in the OAT Destroyer book.
Oh, thank you, Dr. Romano. Guess what I'm doing today?
What?
I'm going to be in the Zoom at 5 o'clock with the students.
All right, good. Bye-bye.
Bye, Dr. Romano. I hope you join in. Shoot, physics, I'm taking the DAP, but this is good for the OAT students. Good luck.